Asteroid danger belongs to living memory, not just the age of dinosaurs. In Siberia, a forest was flattened while trees at the center stayed standing. In Russia's Far East, iron fell as a shower. And one morning, a white trail hung over a city for 2 minutes before the shockwave reached the people watching it. The sky that split Siberia. You spend an early morning in June 1908 at a trading post in the Siberian taiga, much like Semyon Semenov did when the Tunguska event unfolded. The northern sky flares blue-white, and heat reaches you before the blast does. Semenov later described the sky splitting in two while fire spread over the forest. About 40 miles from the center, the pressure wave arrives violently enough to throw him from the porch. Leonid Kulik reaches the devastated region in 1927, almost 2 decades later. He finds trees flattened outward across roughly 800 square miles, an area about 3/4 the size of Rhode Island.
Near the center, some trunks remain upright but stripped of branches, standing like telegraph poles. No impact crater appears. The reason is an airburst, an explosion in the atmosphere rather than on the ground. Modern NASA modeling places the blast at roughly 6 miles altitude and in the 10 to 20 megaton range, with about 80 million trees knocked down. The missing crater becomes part of the answer. Tunguska delivered the damage from miles above the forest floor. The night it rained iron. Winter light covered the Russian Far East on February 12, 1947, when an intensely bright fireball crossed the daytime sky above the Sickened Mountains. Witnesses saw a dark smoke trail stretching roughly 20 miles and lingering after the flash. The incoming body fragmented repeatedly as atmospheric pressure tore it apart, turning one iron mass into a meteorite shower spread across several square miles of taiga. Stand beneath that path for a moment and the scale changes completely. Instead of one object reaching the surface, tens of thousands of iron fragments arrive across the forest, from tiny pieces to masses large enough to punch out craters. Researchers led by Yevgeny Krenov later mapped dozens of major craters and many smaller pits, with the largest roughly 98 feet across. More than 50,000 pounds of material were eventually recovered. The largest intact piece weighs about 3,800 pounds, roughly the weight of a mid-sized sedan, and is displayed at Moscow's Fersman Mineralogical Museum. The surprise was written into the crater field itself. One incoming body had broken into a dispersed iron bombardment before the ground ever had a chance to stop it. The rock that skipped off Earth. On August 10, 1972, a brilliant fireball entered the atmosphere over Utah in full daylight and raced north toward Canada. At Jackson Lake in Wyoming, James M. Baker captured the famous photograph of the streak above the Teton Mountains. Other witnesses recorded the event on film. Picture yourself beside that lake as the object crosses the blue afternoon sky instead of dropping toward the ground. Astronomers call this an Earth grazer, a meteoroid that passes through the upper atmosphere on such a shallow path that Earth curves away beneath it. The object came within about 35 miles of the surface, roughly 5 times the cruising altitude of a passenger jet, then climbed back into space. The fireball remained visible along a long daylight path from the United States toward Canada. Zdenek Sapleka later reanalyzed the trajectory and estimated that the passage stripped away a large fraction of the body's mass, while also changing its orbit. A falling space rock had entered Earth's atmosphere, lost material and speed, and still escaped without reaching the ground. The crater that sickened a village.
Near Caracas in the Peruvian highlands, on September 15, 2007, a stony meteorite survived an unusually deep passage through the atmosphere and struck the ground with enough force to carve a crater about 44 feet across, roughly the length of a school bus. Local witnesses reported muddy water churning in the new hole and a sharp odor around the site. Walk toward the rim with the first crowd and the unsettling part is invisible. People soon reported headaches, nausea, dizziness, and vomiting, while rumors spread that the object had brought radiation from space. Measurements found no radiation. The meteorite itself was an ordinary chondrite, meaning a common type of stony space rock, but the illness story remained harder to pin down. Peruvian officials considered gases released from the ground, including the possibility that impact heating disturbed arsenic-bearing groundwater. Tests found elevated arsenic in local groundwater, but the impact-related illness mechanism was never established cleanly. The impact was real and unusually crater-forming for an object this small. The claimed poisoning mechanism stayed less certain than the first headlines made it sound. The morning two rocks arrived. On February 15, 2013, a brilliant flash crossed the morning sky over Chelyabinsk, Russia, brighter than the sun and captured by dashboard cameras across the region. A long white trail remained overhead while the city waited roughly 2 minutes for the next part. Stand near a window during that delay and the light makes the danger feel finished before the shockwave arrives. Then glass bursts inward across hundreds of square miles. The asteroid exploded at an altitude of about 14 miles and released roughly half a megaton of energy, comparable to about 35 Hiroshima bombs. More than 1,500 people were injured, mostly by flying glass, and roughly 7,300 buildings were damaged. Astronomers were already watching a different asteroid, 2012 DA-14, make a harmless close pass on the same date. NASA confirmed the two objects followed unrelated trajectories. Chelyabinsk therefore arrived without warning, even while another near-Earth asteroid was under careful observation. The event became a planetary defense wake-up call. 3 years later, NASA established the Planetary Defense Coordination Office to organize detection, tracking, and response work across the agency. One chance in 37. Astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi discovered asteroid 2004 MN4 at Kitt Peak in June 2004. After it was recovered in December, fresh measurements pushed the calculated chance of an Earth impact in 2029 to 2.7%, about one chance in 37. Imagine refreshing the published risk calculation that day while each new observation changes the future path. The probability briefly climbed high enough to trigger intense public attention. Then, Spacewatch researchers found 3 faint pre-discovery images taken on March 15th, months before the official discovery. Those photographs extended the observation arc, the span of time over which astronomers had measured the asteroid's position, by about 3 months. With the longer arc, the uncertainty shrank enough to rule out an impact in 2029 later on December 27th. The asteroid eventually received the name Apophis and is roughly 1,100 feet in diameter, about 3 football fields end to end.
The asteroid followed the same path throughout. 3 old images changed what astronomers knew about where it had been, and that changed where the calculations said it would go. The rock science saw coming. On October 6, 2008, Richard Kowalski scanned the sky with the Catalina Sky Survey in Arizona and found a small object moving fast across the starfield.
Orbit calculations quickly showed that it would enter Earth's atmosphere over Sudan in about 20 hours. This was 2008 TC3, the first asteroid ever discovered in space before a predicted impact on Earth. More than 800 follow-up position measurements refined the forecast while the object was still approaching. Sit in the cockpit of a KLM Boeing 747 over Chad that night, and the prediction turns into something visible. Captain Ron DePorter and co-pilot Cohen Van Uden had been alerted where to look, and at the expected time, they saw the horizon brighten in a sudden flash. The asteroid broke apart about 23 miles above Sudan, and later, search teams recovered meteorite fragments from the Nubian desert. The 20-hour interval was only about the runtime of 10 two-hour movies played back-to-back, yet it was enough to predict both the place and the time.
For the first time, an incoming natural object had arrived on a schedule calculated before it hit the atmosphere. The asteroid that looked still. On July 24, 2019, amateur astronomers at Brazil's Soneir Observatory detected an asteroid only hours before its closest pass by Earth. Later named 2019 OK, the asteroid measured between roughly 200 and 400 feet wide and skimmed past about 40,000 miles from Earth's surface, close to 1/5 of the distance to the Moon. Look at an earlier survey image and the difficulty becomes obvious. An asteroid hunter normally spots a nearby space rock by watching it shift against the background stars. But this one's approach geometry made it appear almost stationary until the final days. Its highly elliptical orbit also left only a short window when ground-based telescopes could detect it. NASA later noted additional bad luck around the approach, including the full moon, poor weather at Hawaiian surveys, and Arizona's monsoon shutdown. By the time the object clearly revealed its motion, Astronomers had only about 5 hours of warning before the close pass. The detection failure was therefore stranger than simple darkness. For much of the approach, the object moved too little against the stars to advertise itself as an asteroid. The day humanity hit back. On September 26, 2022, NASA's DART spacecraft closed on Dimorphos, a small moon orbiting the asteroid Didymos. Its target measured roughly 1.5 football fields across. The spacecraft accelerated into the moonlet at more than 14,000 miles an hour as its camera sent increasingly detailed pictures back to Earth. Watch the final transmission with the mission team, and the rocky surface suddenly fills the frame. DART sends one last complete image from about 7 miles away, then begins transmitting another. Only part of that final frame reaches Earth before the signal ends at impact. The silence is the confirmation.
Follow-up observations showed that Dimorphos completed each orbit around Didymos about 33 minutes faster than before. DART had acted as a kinetic impactor, a spacecraft using its own mass and speed to change another object's motion without explosives. For decades, asteroid defense in popular culture meant nuclear weapons and desperate crews. This test demonstrated a quieter mechanism. A precisely aimed collision changed an asteroid moon's orbit by a measurable amount, turning planetary defense from prediction into an experiment humans had actually performed. Subscribe for the next strike Earth barely survived.